Okay, moving on with transformation. So far, we have identified our 7 basic functions, and we have shifted them in any direction. The next transformation that we're going to learn is the reflection transformation, and it is exactly like it sounds. We are going to reflect, or we are going to flip the graph over. So we're going to create a mirror image. And just like the last time, we can do it vertically or we can do it horizontally. So if we do it vertically, we're going to reflect it over the x-axis, which might seem strange, but not so bad if you think about it. If I have my x-axis and I flip it vertically, that means any point here is going to get flipped over there, and any point here is going to get flipped over there. And so now you start to see that that flipping is happening up and down or vertically. Same thing with horizontal. It's going to flip it over the y-axis. So if I have my y-axis, if I have a point here, it's going to get flipped over there. If I have a point here, that's going to get flipped over there. Okay, so let me go to my visual, and hopefully you can start to see how we can reflect these and how that changes our graph. And by the way, these visuals I'm getting from Desmos, so that is www.desmos.com, and I will include the link below my video so you can follow along with these if you choose to do so. Okay, so you see that I have my basic graph here. Hopefully right away you can pick out which function this is. Hopefully you know right away this is y equals square root of x. Now what I want to do is I want to do a vertical reflection. And so that means I'm going to start flipping it up and down. So I'm going to flip it this sort of way. So let me play this here. So here's my normal, here's my reflection. Normal, reflection. So notice it is flipping over the x-axis, just like we would assume it to be. Okay, horizontal, same thing. I have my original function, and now I'm going to start flipping it horizontally, which means I'm going to flip it this way. So vertically flips like this, and horizontal flips like that. Okay, so let's go ahead and let's get this going here. And so we can see that it is now flipping in the motion that we would expect it to flip in. So let's see how this looks in actual function notation. Okay, it happens by multiplying by a negative. If we multiply by a negative on the outside, it reflects it vertically. If we multiply by a negative on the inside, it reflects it horizontally. So hopefully you'll start to see a theme here. Anytime we happen on the outside, that's going to affect our vertical transformations. Anytime we see it on the inside, that's going to reflect it, or that's going to transform it on the horizontal transformations. Now, we don't actually see it here on the reflection, but remember, anytime it's happening inside or horizontally, we want to think that it's happening backwards. Okay, so if I were to go back and show you the actual values of those graphs, let me pause it here for a moment. Notice I have a times the square root of x. If a is positive 1, I get my normal graph. If a is negative 1, I get my reflection. So I'm multiplying it by a negative value. So negative value on the outside reflects it vertically. Okay, horizontally. All right, notice I have square root of b of x. I just chose a different variable there, but it would have worked the same way. If b is a positive 1, I get my normal graph. If b is a negative, so me multiplying it by a negative, I get my reflection. On the inside, it reflects it negatively. Okay, now this one's really easy because this one is a basic function and we can see it flipping left and right. But let me actually give you a different function, and let me actually zoom out on this here. Okay, so this is back to a vertical reflection. So this is my normal graph. Let me actually multiply it by a negative. This is my vertical flip. So notice it flips over the x-axis. My point down here goes to my point up there. my point, my line here goes to my line up there. So we can see that this is flipping vertically. It's flipping over the x-axis. If you wanted to see a more complex example with my horizontal, I have the same graph. Let me zoom it out. Okay. Here's my normal. Here's my reflection. So notice that I have the same graph. I have my point down here. When it was vertical, it flipped up here. When it's horizontal, it's going to flip over here. So let me go ahead and see that flipping. And so here we see that it's a horizontal flipping. So you see that this flipping in different directions completely changes the graph. It doesn't mean the same thing. Okay, let's actually get to an example then. So I have example 2. Given g of x is equal to negative times x minus 3 quantity squared. Same steps, basic function, how is it transformed, and then the graph. All right, so notice here that I don't only have the negative, which is going to reflect it, but I also have the shift that we've learned from last time. So we can see that these transformations can happen in several different ways all at the same time. So I suggest that you pause the video and see if you can answer this question on your own. Okay, basic function is y equals x squared because we see that we have the quantity squared. I already told you that we had the negative, which is going to reflect it, but we need to know in which direction. Since it's on the outside, it's going to reflect it vertically, which means it's going to reflect it over the x-axis. The negative 3, since it's a subtraction means it's going to shift. If it's on the inside, notice it's on the inside of my operation here, the inside of my parentheses. That means it's going to do it horizontally, and it happens in a backwards fashion. I would think, oh, it's negative, it's going to shift left. Backwards fashion means it's actually going to shift right 3 units. Okay, now we need to decide which one of these is happening first, because if I reflect and then shift it, that's going to give me a different graph of if I shift it and then reflect it. So we need to know which way we think about it. Well, we think about it in the same PEMDAS rules, your order of operations, that we have ever since the beginning of semester. Parentheses, exponents, but we want to do multiplication and division first before we do addition and subtraction. So since this negative is multiplied, we're going to do our reflection first before we do our shifting. Okay, let me get my basic parabola graph up here. If you need to identify the key points, then I would suggest that you do so. And so here is my parabola. And so what I'm going to do now is I'm going to take each of these key points, I'm going to reflect it, and then I'm going to shift it. So let me start with the origin. Well, if I reflect it over the x-axis, I don't actually move it because it's on the x-axis. So my reflection doesn't change, but then I shift it right 3 units. So I'm going to go 1, 2, 3. So that's where my new vertex is going to be. Okay, let me do here. If I reflect it, it moves it here. And then if I shift it right, 1, 2, 3, that moves it here. If I do this guy and reflect it, it moves it down here. And then shift it, that moves it here. And I can do this with all the points if I feel necessary. 4 reflects to -4, shift right, reflects to this point right here. Again, 4 reflects to -4, shifting right gives me this point right here. And if I were to connect all of these values, this would give me my transformed graph. So here is my parabola that's reflected over the x-axis and then shifted right 3 units. So not only can we do that, but we can also identify the key things that we want to know. We can figure out that my x-intercept is at 3, 0. We know that my domain goes forever in both directions, left and right. My range now, it's going to change completely Because notice the range when we did it with our basic function went from 0 to infinity. Well, since I reflected it, that's going to adjust our range. It goes down forever, so negative infinity, up to this value here, which is 0. So since I reflected my image, that also reflects my range. Okay, now we talked about this graph in terms of the transformation, but we actually could have graphed this graph in a different format. So I'm just trying to connect all the dots from the class here. Remember back when we were trying to graph parabolas in general, just focusing on parabolas, we had the vertex format. The vertex format was f of x equals a times x minus h squared plus k. Where the vertex was at hk, well, our vertex would be at 3, 0. Notice our vertex is at 3, 0. If our a was positive, our parabola opened up. If our a is negative, our parabola opens down. And so this thing here tells us the exact same thing that this thing in our transformation tells us. So we have two completely different pieces of information that gives us the exact same graph. So kind of cool that our math class just isn't one thing telling us one thing. We have lots of different pieces connecting the dots all across the board. All right, I'm going to stop this video here. And in the next video, we're going to be focusing on our last way to transform graphs.